Hello and welcome to this first part of a 5-part webinar series from Element 14 and BeagleBone.org. Over the next 5 weeks, Jason Kramer from the BeagleBone.org will be going through selections from the recently published book, the BeagleBone Cookbook. Today's presentation, Jason will be going over how to play audio recordings using the BeagleBone Black. If you have any questions for Jason throughout the webinar, you can ask him by using the Q&A function found in the drop-down menu of the green taskbar on the WebEx application. If you have any technical issues throughout the presentation, you can chat me at Premier Farnell Webinars directly by using the chat function found on the same screen. Now, a recording of this presentation will be made available on the event page if you want to revisit it or share with a friend, and you can ask any follow-up questions you may have for Jason on the community underneath the event page. So without further ado, I'm going to turn it over to our presenter, Jason. Take it away.
Thanks. Thanks, David. So yes, my name is Jason Kreidner. I'm a co-author of the book BeagleBone Cookbook, and I'm also a board member at the BeagleBoard.org Foundation, and I'm an employee of Texas Instruments and the entire applications team. I'm currently on the BeagleBoard.org Foundation board. There's 2 of us that are employees of Texas Instruments, and then 3 other people from outside. So it's an independent nonprofit, and we'll talk a little bit about BeagleBoard itself, but try to spend a lot more time talking about BeagleBone and what you can do with one. In this series, we're going to start out pretty simple. Here we're going to do playing and recording audio, and each of the presentations in this series are going to be a little bit more complex as we go further down. So, forgive me if this one is a little bit beneath where your skill level is, seems a little bit too simple for you. Don't decide that you don't want to tune into some of the later ones, because we will be diving a lot deeper in to the topics with BeagleBone moving forward. That said, we're going to start at the basics of telling you what a BeagleBone Black is. What really stands out about it is that you're ready to get started using it very quickly, and then it's easy to start exploring using embedded Linux on a single board computer and expanding that as really without any barriers. So it's really easy to get started, and then you can go all the way to end prototypes and products. It's a flexible open hardware and software development platform. You can get the schematics, you can get the everything, the information, all the devices on the boards without signing NDAs. You can get the layout files and edit them, and all of the devices on the boards are available through distribution in quantity 1, so you can actually go and make these things. And everything that you need to do to get started is right there in the box. You plug it in. There's an IDE built in. It's flashed to a Linux distribution. The USB connection acts as both power and as a network cable. It even acts as a flash drive to serve off the drivers for getting connected if you're not using a Linux host, if you're connecting up to a Windows or Mac PC. So you can talk to the board and get going without having to go to the internet. Then you can, of course, go to the internet to get updates. And there's a big ecosystem around the BeagleBone Black that's proven. So there's a lot of people you can work with who've either done derived products, a lot of different add-on boards that you can use to get you going. So really, this is the most flexible platform out there today in open source computing and a very affordable entry point. Just looking a little bit at the high-level board features, it does include an Ethernet port for getting to networks. It includes both a USB host, which will make a lot of use of. It means you can just connect up standard USB peripherals and work with those. It does include an HDMI port for connecting up TVs and monitors and displays. So that you could use it like just a regular desktop computer, hooking up using a USB for the keyboard and mouse and hooking up a monitor to the HDMI. But a lot of people choose to use it, and I generally teach people about using it more as an embedded device where you're actually accessing it remotely, such as over the network, or through how I'll be showing us is going through the USB client port. So you can emulate all sorts of USB peripherals. You can even use the whole system as USB sniffer. If you wanted to, you'd actually connect up both the USB client and the USB host and monitor the traffic in between, right? So it's a very flexible USB platform. It's all built around a 1 gigahertz TI Citara processor. It's an ARM Cortex-A8. It's just a reasonably fast superscalar processor at gigahertz. But what really stands out about the BeagleBone Black is all of the I/O capability. There's 65 digital I/O, there's analog inputs, there's a ton of I/O peripherals, including hardware pulse width modulators, and there's a couple of these real-time microcontrollers on there that are running at 200 megahertz and are free for you to program and use. So it's all that expandability that really draw a lot of people to the BeagleBone Black, and of course it's very affordable to get started doing development with. It comes with the USB cable and pre-programmed, so you don't need to go out and buy a micro SD card or a power adapter to start using it. You just use it right there. It comes with the 4 gigabytes of onboard flash with Debian programmed on it. And of course that onboard flash is a little bit more reliable than some of the micro SD cards that you can get out there, and being 8 bits wide, a little bit faster. So you don't need to go out and buy an extra microcontroller board or all these different peripherals to get started. The only thing that we've gone out and bought in order to do this talk is a USB audio adapter. And a lot of the experience for BeagleBone is meant to get entered into very quickly and easily, especially through the web browser. Right? So if you want to start doing interactions between a computer either over the Ethernet or over the USB to your BeagleBone Black, it's very simple. You can look at the tutorial. This is one, this BeagleBone.org .github.io, Bone 101, the updates of the tutorial. It's actually served up right off the board, and you can go and have interactions between your web browser and the board and learn how to program it that way and kind of grow into utilizing Node.js and Linux. And of course, you're not limited to just doing that because it's a full-on Linux computer. You can go on to Python, C++, and Java, or just about any really way that you want to program it, thanks to Linux and the abstractions that Linux provides, and the fact that it's a really open platform. And this is example of one of the things that's served up off the board. So you don't have to go and install anything on your computer in order to get started. You don't have to go and install SSH clients or anything like that, because built into the BeagleBone Black is a IDE called Cloud9 IDE. So this is not something that is hosted in the cloud and then you go out and access the cloud in order to do this. This is actually being web served off of the BeagleBone Black, and you simply open up your web browser, point it to the BeagleBone Black, and you can see that integrated development environment. In fact, I'm actually running that here within my Chrome browser, right? So you'll see I'm serving up a PDF file that I've put on my BeagleBone Black, and then I'm viewing that through this Cloud9 IDE, such that I can actually bring up the console and do interactions. So if you see, I can list off the PDF files I have in this directory, and that's exactly what I'm looking at. So it doesn't really take anything special to go and serve up web pages, to edit them, to edit Python, JavaScript, C programs. You don't have to go and learn a bunch of new tools, but of course you have really, really super simple access to the Linux command line. For those of you wondering, I can even run things like the VI editor directly within my web browser. All right, so it's a very flexible platform for doing development without having to install anything in your platform. So let's look a little bit about how BeagleBone Blacks are used today before diving into the audio portion. right? So there are tens of thousands of developers taking the BeagleBone Black and actually building connected devices today. They're different medical equipment, medical analysis, information management, even things like this open qPCR machine for sequencing DNA is built around a BeagleBone Black and made open. People are doing retro gaming, handheld gaming, lots of different applications there. And there's a huge influx of people developing IoT or Internet of Things devices. I like to think more of some of the different applications like home automation, like thermostats, or my sprinkler system happens to be controlled by a BeagleBone Black, where it can actually go out and look at the weather tomorrow and figure out whether it's going to, or later in the day, and figure out if it actually needs the water or if the rain's going to take care of it. Tons and tons of applications in robotics and software-defined radio, different types of robotics like flying ones, and connecting up to all sorts of systems like in the automotive, and a lot of what I call citizen scientist activities. If you've ever heard of OpenROV, it's a fantastic project, and they use BeagleBone Black in their systems. I could really spend just weeks talking about that, so I'm trying to limit myself to just a couple minutes. And now we'll dive into some of the considerations of audio. Well, first, let me stop and say, plug the cookbook. In this webinar series, we're going to be pulling recipes out of BeagleBone Cookbook that's co-authored with a professor out of Rose-Hulman University, Mark Yoder. So he did all the hard work of actually writing the cookbook. It's mostly written over the summer. We'd talk on the phone in the morning and tell him how to do different types of things with his BeagleBone, and then he would actually put that down into the book. And we ended up getting 99 recipes covering a lot of the stuff that people wanting to do when they get started with electronics and single board computers and the BeagleBone. So it's a lot of, how do I manage the contents of the SD card and get my images right so that I know that I've got what I need to run the examples, to pull different people's examples out and to run those. Sensors, that's everything from, here we'll be looking at audio sensors, but it's everything from touch to, and force to temperature to light. There's all sorts of sensors covered in there. Some of the different types of interface categories that you'd be looking at, like GPIO, I2C, the analog inputs. So we cover a lot of those items. And then, there's sensing, and then there's output, right? So that's everything from LEDs and LCDs to actually flipping relays so that you can turn things on and off. And we broke out motors separately because there's really a lot to cover when it comes to driving motors. So we look at the various different types of motor technologies and how you can get and to drive those with BeagleBone. We see a lot of people building machines that build things, even ones that people are actually building printed circuit boards and assembling printed circuit boards with BeagleBones. We broke out an Internet of Things chapter, and that's mostly about some of these tool frameworks like Node-RED and getting connected to the internet and using some of the internet APIs that are out there to log and analyze data. And then we dived in just a little bit into the kernel, rebuilding the kernel, understanding some of the kernel interfaces, and then go a little bit further into real-time I/O, just looking at the various types of solutions for solving different latency problems. So looking at how you can continue to reduce latency, stepping up all the way to programming the microcontrollers, and then a little bit of hardware in terms of add-on boards with the capes. So the BeagleBone Black doesn't have audio jacks directly on it. One advantage of that is that when you do add audio, you can really control what types you want and really control the quality. A lot of times when you have a single board computer and you put the audio jacks on it, it's only going to be as good as the noise that you can kind of cut off of the board. So by doing something, the digital analog and the analog to digital conversion off board, you can really do a lot more to control the quality. We found just a lot of people really wanted to do some very specific things, and so it was easy enough for people to just add on USB or TV or anything to get audio, so we just ended up leaving that off the design itself. So there is a built-in HDMI audio, which you can simply plug the micro HDMI connector into a TV and play audio back that way. There are audio capes available, and those will build off of the many different serial ports that are on the cape headers, including SPI and I2S, and controlled via I2C. So there's existing drivers and example hardware for different qualities of audio interfaces if you want to put the codecs down on an add-on board yourself. One of the nice ways I found to do audio is sometimes you'll have Bluetooth speakers, or you want to connect it to your car, for example, and there's really nice support for USB Bluetooth dongles, and then using the BlueZ A2DP stack for doing audio output. But we're just going to do a direct USB audio adapter. And these are really affordable, easy to find adapters. I've seen as low as $2.99 out on Amazon. So if you just search Amazon for Linux USB audio, and really if you choose any USB audio adapter that supports the standard audio class, you'll be fine. And I've seen that with the most off-the-shelf USB audio adapters. In fact, I haven't found anyone that doesn't work with Linux. But you just need to make sure it works with Linux. And because we use very recent Linux kernels, you have the recent Linux kernel options, and you have the USB standard, that should just work just fine with the BeagleBone Black. Let's see anything else to add there. Also some web cameras, a lot of them have audio inputs, and those work great as well. So before we actually get to doing the audio in and out, you need to make sure that you have your BeagleBone Black, you understand how to connect it and how to get started doing things like getting into this Cloud9 IDE. So there's instructions out on beaglebone.org/getting-started. Or if you have the BeagleBone Cookbook, you can look at recipe 1.2. It'll walk you through the steps of getting connected to your board and starting to use its interface. If you have an old software image, you can find out what version of the software image you have. We have a file on here called etc. dog tag, and you'll see that I'm running the April 23rd, 2014 image for these particular examples, which is what a lot of people are still shipping with today. But we do have newer images. If you want to update to some of the newer images, you can look at the beagle.org/latest images for the well-supported images from the community. There's other places where you can get newer images if you want those. So this is a picture of the computer I'm using to actually do this presentation, and the BeagleBone Black I'm using here for this presentation. Just plugged in this USB audio adapter ahead of powering up the board. So some of the older kernels don't really like USB hot plugging. So if you're seeing an issue where you're hot plugging it and the adapter's not coming up, then you may want to have booted it with the adapter already installed. Now that's not always a problem, and newer kernels handle that rather nicely. But just to try to eliminate your headaches and frustration, try booting up with the adapter installed ahead of time and see if that works for you. Also, typically USB power. There's enough power left over from the board that it'll power up your USB audio adapter just fine. Now, that's not always the case. Some of the adapters can chew up a lot of power, especially if some that have a lot of features to them. So if you are you seeing some issues, try plugging in the 5-volt power in addition to the USB power, just to make sure that your device is getting powered up sufficiently. You can also put a USB powered hub in between the BeagleBone Black and the USB audio adapter. And simply, you probably want to just verify, if something's not working for you, just go back and verify that things are discovered properly. And see here, if I do the LS-USB as a Linux command for discovering USB connected devices, you'll see this audio adapter is discovered. And you can do lots of different things with LS-USB. You can print out some additional details here about your device that is connecting. Let's go all the way back to this. Here we go, to the audio adapter, and see a lot more information about things through the USB enumeration. All right. Also, I said there's a D message here. If you're not familiar with DMESG, that's a very useful command. This actually prints out the kernel log. So the different messages that are coming from the kernel to the console. Because we're connected up over USB here, we're not actually seeing the console. So we can actually just type DMESG, and it'll print out the contents of the console log. So that can be helpful for debugging and to find out if it's actually discovering the USB audio adapter or not. All right, so now we're ready to do some playback, but we need to actually discover where the device is according to ALSA tools, the Advanced Linux Sound Architecture. So the tool we're going to be using is called A-Play, and it does come shipped on the board. A-Play, and we can actually look at the details of the command here. I'm using J and K to scroll up and down, but you can also use arrow keys. This will give you the details of these functions. If we do A-Play-L, we'll see here that we have 2 sound cards connected. One is the built-in black HDMI output. The other one is this what's called generic USB audio device. So you can see there that we have both of those discovered through the A-Play-L. Now, if we're looking for the interfaces, we do capital L, and there we got the names for the different outputs. And you'll see 2 different cards. You have card equals black and card equals device. So that allows you to point to either the HDMI or the USB audio. And we're simply going to play back using the USB audio, card equal device. And there's built-in, the ALSA has some examples. So we'll just use the WAVE files that are provided there. If you needed to copy some other files over from the computer, of course, use the Cloud9 interface to transfer those. Or if you're familiar with Linux, using standard SCP tools for secure copy. Did I typo? Center. There we go. Just copy and paste that just to make sure this works. All right. So center. Hopefully you're able to hear that just fine over the speakers, but you can just specify the device you're putting out. And of course you can remove this by changing the default device, and I'll show you how to do that here coming up. Now, if you're wanting to use the recording, you'll likely want to adjust the input gain. And so there you want to start up ALSA Mixer, and that is a console interface application that you can see here run. Again, just running this under the Cloud 980 from the command line. And maybe I can put this full screen. Just a little bit. There we go. Now we can see the output. So we can actually change the microphone gain here. So we can scroll up and down to actually change the microphone gain and go ahead and escape to say that. If I had to change cards, I could do function F6. It allows me to choose between or press the function 6 button. I can change between the different devices. So I can use that to configure. And now if we want to, again, if we want to look at the documentation, we command A record. And just to do a simple recording, A record. Avoid save myself some typing. So it seems when I configured the default parameter for the board, I didn't realize when I changed the tilde.a sound RC, it made this argument not work, but you just leave it without. This is a test that I'm doing here for the webinar. Use Control-C there to get out and do a play s.wave. This is a test that I'm doing here for the webinar. So you see there, doing recording is also very straightforward. And this is the step I did to change what the default audio. And so if you're doing different applications and you're going to look for this file, this tilde says that I'm writing it into the home directory. Here I'll be writing it, written it into the home directory of the root user. So if I do a cat tilde.a sound src, see that that's actually there in the a sound rc file. So that means that I don't have to actually type the device name. It's just set up as default. You can find details for that on the ALSA website to find out how best to configure a sound RC file. Now I'm able to use some other tools. I'll just do an example here of flight.
This is an example. Can you understand me?
So that's a text-to-speech utility called Flight. It's part of Debian. So if you wanted to use that, you can just do an apt-get install Flight. But your BeagleBone does need to be connected to the network in order to do that. The USB connection won't necessarily be bridged over. So you need to plug in an Ethernet or a USB Wi-Fi dongle in order to get out to the internet. Or configure network bridging. You could also do things like here I've actually copied the .deb files over to my board and then did dpackage-i to install those. And you can just download those off of packages.debian.org. So there's lots of different ways to put in applications, lots of different audio tools that you can go and work with at this point. So you can do things programmatically, with the different audio libraries and with ALSA. So there's really an open field from this point. If you want to learn a little bit more about the Advanced Linux Sound Architecture, I highly recommend reading the documentation over at alsa-project.org. So it includes user space libraries for doing application programming. It supports a lot of different devices, so all those different types of interfaces we were talking about, the HDMI, the Bluetooth, the add-on boards, the codecs that you want to throw on board, if I2S or SPI. codecs. So there's a lot of different flexibility in that ALSA software. It's a little bit much for a 30-minute webinar. So highly recommend that you check all that out. There's also a really nice set of tutorials that a 13-year-old Alec Mabry, he's actually going through the BeagleBone Cookbook and documenting a lot of his experience in videos. He has one here specifically on the example I just showed you of making your BeagleBone talk. So I highly recommend checking out Alec's tutorial. He's got some fun little projects he's doing. And, continuing to check out the links on BeagleBoard.org /cookbook, providing any feedback on the book through the O'Reilly link there. So at this point, I'm going to flip over to the questions. Did anybody have questions at this point? I know it's pretty simple and straightforward items here. So I hope you not have too many problems getting started. Again, we're going to have much more elaborate recipes as we move forward, more interesting things you can do. This is a little bit simple, but we'll just make sure that people knew how they could do some basic audio interactions. It's a fun thing to get started with, doing digital signal processing on algorithms, doing their audio effects. A lot of people do their senior projects with BeagleBone doing guitar effects or very interactive audio. Because it's one thing is you've got the BeagleBone Black there with the audio capability, but it gets really exciting when you start wiring up things to do connected and physically interactive. People build their own musical instruments out of BeagleBone Blacks. They do interactive art displays that include audio capabilities, so it's been really popular. There's some fantastic tools on top of Linux. There's a thing called Pure Data, which is a really fantastic Linux tool. There's also Super Collider as an option. So there's really a lot that you can go and do from here. So I really appreciate your time in attending this webinar, and I hope that you will tune back into the future webinars where we do more exciting things with the BeagleBone Black. Thanks a lot.
Thank you, Jason. And just to let everyone know, you can find more information about the upcoming webinars featuring Jason, and he goes through more of the BeagleBone Black recipes on element14.com/webinars. And there's a link in a banner there with Jason's face, as well as the front cover of the book on there as well. So tune in next week. Jason will be going through the second recipe, displaying GPIO status in a web browser, and that will be taking place at the same time just next Tuesday. So thank you, Jason. Thank you all for attending. We will see you next week. Take care.